Ever wonder what's really going on when something burns, or fizzes, or just suddenly changes color? These aren't magic tricks. There are these incredible transformations happening all around us, all the time. So today, we're going to pull back the curtain on the amazing world of chemical reactions.
Well, the answer is all about chemical reactions. They're the processes that take one thing and turn it into something completely new. We're about to dig into how they work, and, even better, how you can spot them in action for yourself.
I mean, just think about a sparkler, right? One moment it's just this plain, dark stick. The next, poof, it erupts in this incredible shower of light. Yep, that's a chemical reaction.
Or how about this one? You twist the cap on a bottle of soda. It's a totally still liquid, but the second you open it, it just fizzes into life. You guessed it, that's a chemical reaction too. And of course, in the lab, you can mix two completely clear liquids and suddenly get this wild eruption of foam. Now here's the really cool part. All three of these things, the sparkler, the soda, and the foam, are all powered by the exact same fundamental process. Okay, so what is this process? To really get it, we need to define what a chemical reaction actually is. Let's break it down. At its very core, a chemical reaction is just a process where substances, you can think of them as ingredients, mix and rearrange themselves to become something brand new. It's a total transformation from one thing into a completely different thing. A perfect example, one you might have even tried, is mixing baking soda and vinegar. We start with those two substances, and they react to create totally new ones. And that includes the carbon dioxide gas that's responsible for all that fantastic fizzing and bubbling. We can actually talk about this like we're cooking. The ingredients you start with, in chemistry, those are called reactants. And then, when they combine and do their thing, the completely new stuff you create is called the products. It's seriously just like baking a cake. Your reactants are the flour and eggs, but after that chemical change in the oven, your product is a cake. Okay, so we know what a reaction is, but how do we become chemical reaction detectives and spot them out in the wild? Well, it turns out there are some classic clues to look for. And the really good news is you don't need a fancy lab or a white coat. Nope. You just need to know the telltale signs that chemistry is happening right in front of you. And here they are, your official detective's checklist. We're talking about things like bubbling gas, a sudden color change, light popping out of nowhere, or even a shift in temperature. If you see one of these, you're probably looking right at a chemical reaction. Let's check a few out up close. First up, one of the most obvious signs of all, making a gas. All those bubbles, all that fizzing, that foam overflowing, it's all just new gas that's being created and escaping from the liquid. This is exactly what's happening in your soda can or with that baking soda and vinegar experiment. It is undeniable proof that a reaction is going down. All right, another really powerful clue is a sudden, totally unexpected change in color. Now, this isn't like just mixing paint. This is when new molecules are actually formed. And those new molecules just happen to look different to our eyes. So something that starts out totally clear can suddenly become this vibrant, brilliant color, a sure sign that new chemistry is happening. And for our final clue, we've got one of the most dramatic signs there is, the production of light. This brings us right back to where we started. All of that intense energy that was holding the original stuff together gets released, and it escapes as light. A campfire, a firework, a sparkler. These are all chemical reactions that are so energetic, they literally start to glow. So, now that we know how to spot a reaction, let's take things a step further. In science, there are two main ways we study these changes, by observing them and by measuring them. Think of it this way. An observation is what you notice with your senses. You see the bubbles, you smell some smoke, you feel the heat. A measurement, on the other hand, is when you pull out a tool to get an exact number. It's the difference between saying, whoa, it got hot, and saying, the temperature increased by 20 degrees Celsius. And you can see that difference right here. On the left, we can observe a bunch of stuff with our eyes. Foam, smoke, color changes. But on the right, we're using a tool like a thermometer to measure a specific change with a lot of precision. And for scientists, both of these are absolutely vital. So, how does a scientist go from just watching something to actually measuring it? Let's look at a really clever example. Remember our first clue, that a gas is being produced? We can see the bubbles, sure, but how could we possibly measure how much gas is being made? It just floats away. Well, the solution is so simple.
It's brilliant. You just put a balloon over the top of the flask. It captures all the gas that's produced. As the balloon inflates, you get a tangible, physical measurement of one of your reaction's products. It's pretty smart, right?
From the toast you make for breakfast to the leaves changing color outside, chemical reactions are happening everywhere. Now you know the clues. So the question isn't whether you'll see one. The question is, what's going to be the first one you notice?